Renowned for pushing the boundaries of what's possible in the automotive world, Tesla Motors has consistently led the charge with groundbreaking advancements. Among its latest achievements, Tesla Giga Castings has emerged as a promising technology that has sparked both curiosity and skepticism. Does the Giga Casting mean a greener future with reduced emissions and energy consumption? Can these massive castings really hold their own in a crash? These and many more questions are what we're going to be answering in today's video. We'd even be shedding light on how Tesla's Giga Casting approach holds up against traditional unibody vehicles that utilize advanced high-strength steels. This is a two-part video as it was difficult to put everything in a single video. I will be making the second part in the next few days. With that being said, let's get going. Tesla Giga Castings, revolutionizing car crash worthiness and repair. Research has actually shown that the use of aluminum in light vehicles has been on the rise for quite a while now. We're talking decades. It's gone beyond 500 pounds, that's around 227 kilograms per car in North America, and 396 pounds, about 180 kilograms per vehicle in Europe. And for the longest time, castings were the stars of the show. But lately, the spotlight's shifted towards sheet and extrusion applications. And that's why aluminum's stealing the show. The accelerating electrification of vehicles has only continued aluminum's growth trend while also changing the product mix. In the past, castings were the go-to, especially in the powertrain of traditional cars with internal combustion engines. Think A380 or 319 alloys. Those were the stars. But with hybrids and electric vehicles in the mix, the script's getting flipped. Castings are taking a backseat, especially in hybrids with smaller engines and battery electric vehicles that don't even use those traditional engines. Now, aluminum's journey is shifting gears. It's not just about the powertrain anymore. Nope, it's making its mark on car bodies, chassis, battery trays, you name it. And guess what? Sheet and extruded products are stealing the show. Castings aren't the headliners anymore, except for some specialized structural components. So basically, aluminum is evolving to become the superhero of modern car parts, using cleaner and more advanced alloys to save the day. Presently, a higher aluminum content, particularly in assemblies involving sheet metal and extrusions, equates to escalated costs. Also, if primary aluminum is utilized, it also contributes to a heightened carbon footprint. As a result, original equipment manufacturers and their suppliers are actively engaged in endeavors to curtail both the material and processing expenses associated with their components. This drive is accompanied by a concerted effort to enhance production quality and bolster sustainability measures. Specifically, the augmentation of recycling content across various types of aluminum parts has emerged as a pivotal strategy in this pursuit. This multifaceted approach seeks to mitigate costs, amplify eco-friendliness, and elevate overall product quality, an endeavor that underscores the dynamic nature of the aluminum industry's ongoing evolution. But in the last few years, a new trend is starting to catch on, initiated by Tesla. They're into this cool trend using Giga castings. Some folks call them mega castings. Basically, these big cast parts can pack in loads of different components into one massive casting. It might change how cars are made, how aluminum is used, and even shake things up for different product forms in light vehicles. In simple terms, it might boost casting growth and slow down the growth of sheets and extrusions. Tesla employs two substantial Giga castings that fulfill the roles of the front and rear underbody within their Model Y. This paradigm shift significantly alters the conventional unibody design of automobile chassis and concurrently rationalizes the manufacturing process. In a comparative analysis with the Model 3, these dual castings supersede a total of 171 constituent parts, predominantly encompassing sheet stampings and some minor castings. This strategic substitution culminates in the elimination of 1,600 weld points and the displacement of 300 robotic units from the assembly line, thereby effectuating noteworthy reductions in both capital expenditure and factory floor utilization. The fabrication of these sizable castings is orchestrated by means of an expansive apparatus referred to as a Giga press. Noteworthy is its capacity to generate locking force to the magnitude of 6,000 tons with the added theoretical potential to yield up to 45 castings per hour. Several other automobile manufacturers, including Volvo and its electric vehicle subsidiary, Polestar, have chosen to emulate this approach and have also made substantial investments in GigaPress technology. It's worth noting that Volvo labels these structural elements as mega casting. Volvo's objective is to engineer multiple vehicle models capable of leveraging the same mega casting technique for their body-in-white components. This entails integrating attachment points even for items like suspension arms and electric motors. Notable automotive entities that have publicly embraced, or at least expressed intentions to follow this paradigm include Mercedes-Benz, VW, Toyota, General Motors, and Hyundai, as well as emerging Chinese electric vehicle startups like NIO and Xpeng. And to add to that, there is a cadre of other original equipment manufacturers discreetly exploring or actively developing Giga casting methodologies. Car body Giga castings are mainly being used to integrate aluminum and steel sheet metal stampings. This might have a minor effect on the growth of aluminum sheet content in vehicles, while also transitioning certain steel sheet components into aluminum castings. On the other hand, extrusions will experience minimal influence due to certain elements like crash boxes performing better in hollow extruded designs than in open casting designs. In the context of battery trays, there could easily be a modest impact on extrusion content as Giga castings replace some extrusions and multi-material assemblies. However, these battery tray castings won't incorporate sills or collision rockers, as hollow extrusion designs demonstrate superior performance compared to integrating these components into castings. Overall, the influence on aluminum sheet and extrusion content is expected to be gradual and not highly significant in the long run. Instead, Giga castings will contribute to an overall increase in aluminum in vehicles, which will, in turn, reduce the proportion occupied by steel sheet stampings. Now let's look at some of the concerns Tesla's Giga casting raises. The foremost concern surrounding Tesla's Giga castings is repairability. With an assembly involving multiple pieces, the mechanic can simply remove and replace the damaged or defective parts. But the worry with a Giga casting is that the entire casting would have to be replaced, which is cost prohibitive or even impossible. However, careful examination reveals Tesla's engineers have designed the Giga castings with forethought. They have placed the castings deep within the vehicle structure, concealed under 10-15 centimeters of rocker, wheel wells, and bumpers. Moreover, the wheel wells are strategically positioned to act as absorbers in low-speed impacts, safeguarding the Giga castings from undue stress. While a side impact at moderate speed might cause damage, the structure's broadside and structural webbing should still dissipate and distribute impact energy effectively. Comparing Tesla's Giga castings to conventional unibody construction sheds light on the similarities and repairability challenges. Unibody vehicles formed from multiple smaller pieces face reduced repairability, as significant damage to any part can impact the broader structure. As auto manufacturers shift to advanced high-strength steel for weight reduction, repairs with these materials also pose challenges due to reduced repairability. Hence, Giga casting's potential need for a replacement casting in the worst case scenario would mirror the unibody's challenges with advanced steel components. Concerns over the strength and weldability of Giga castings have also been raised. However, Tesla's utilization of 3 Series aluminum alloy should facilitate weldability in case of cracking. Deep diving into the features of Giga presses. Tesla's alloy indications suggest that Giga castings will hold up well under high-speed impacts. Additionally, the Giga castings have embedded crash absorption rails, which can be replaced in case of serious accidents, further bolstering the overall crashworthiness and repairability. Then of Tesla's strengths lies in its advanced driver assist safety systems, which result in fewer accidents. Consequently, Tesla vehicles boast a different risk profile, potentially offsetting any higher repair costs associated with Giga casting. As a testament to this advantage, Tesla has initiated its own insurance service, Tesla Insurance, to offer competitive rates to its vehicle owners. This unique combination of superior safety systems and affordable insurance may ultimately counterbalance any potential increase in repair costs. Beyond crashworthiness and repair, Tesla Giga castings also hold significant environmental implications. The use of aluminum as the primary material reduces vehicle weight, leading to lower energy consumption and reduced greenhouse gas emission. While aluminum replacement parts may be more expensive due to the material's higher cost, the overall impact of Giga castings on reducing the lifetime energy consumption of vehicles is noteworthy. This reduction in energy usage can translate to a reduced total cost of ownership, making Tesla vehicles more attractive to environmentally conscious consumers. A number of benefits arise with the use of Giga castings. For instance, they streamline the number of components within a vehicle, typically the frame or underbody, which usually consists of numerous stamped sheet components, along with a few castings, can be consolidated into a single large casting. This consolidation contributes to lowering the overall weight of the car. This aspect holds particular significance for battery electric vehicles, as it extends their range and enhances overall efficiency. But it's worth noting that the weight reduction isn't automatic, given that castings have specific thickness limitations and cannot be much thinner than 2 mm. In comparison, sheet stampings can be manufactured with thicknesses as slim as 0.7 mm, often exhibiting greater strength than casting. By using one large casting, the vehicle's bill of material becomes less complex, which makes the manufacturing and assembly of the car an easier and quicker process. It also leads to a reduction in the necessary capital investment. This approach is notably more feasible and advantageous in a greenfield factory setting compared to a brownfield one. In a greenfield facility, the layout and design can be purposefully configured for the anticipated streamlined assembly process and reduced space requirements right from the start. Conversely, a brownfield factory would necessitate a redesign, potentially rendering other still functional equipment suddenly outdated and non-adaptive to the new approach. The utilization of a larger casting leads to a reduction in supply chain logistics, yielding favorable cost and environmental outcomes. The assembly line becomes shorter, and the car assembly process is quicker, thanks to the reduced need for welding to join smaller components. Tesla, for instance, has indicated that the adoption of Giga castings has led to cost reductions of up to 40%. Throughout other sources have approximated this at 2030. Why? This development has enabled them to produce Model I vehicles within a span of just 10 hours. Likewise, Volkswagen intends to embrace this novel approach to car assembly, leveraging the technology's less labor-intensive method of joining metals. This strategy allows for cost-effective car assembly even in high-cost countries. Another possible advantage of Giga castings in cars is that it might offer an added benefit of improved crash performance. However, it's crucial to recognize that differing viewpoints exist on this matter. Tesla initially tackled crash performance concerns by outlining the shock-absorbing qualities of Giga castings in crash scenarios within their patent filing. Yet, contrasting viewpoints consider crash performance to be a drawback due to the constraints imposed by the limited choice of alloys and production process limitations like wall thickness restrictions. As mentioned earlier, it's widely acknowledged that hollow extruded profiles have a greater capacity to absorb crash energy compared to open section castings. In conclusion, Tesla Giga castings represents a revolutionary step in automotive engineering, promising to revolutionize car crash worthiness and repair. As Tesla continues to innovate, the automotive industry awaits further revelations from this groundbreaking technology. Giga castings have the potential to reshape the landscape of car crashworthiness and in repair, setting new standards for safety and sustainability. Thanks for watching. Until next time.